In this video, I'm going to discuss how to simplify and evaluate algebraic expressions. So let's go ahead and get started. So first of all, it says a term is a constant, a variable, or a product of constants and or variables. So it's important to know what a term is. So it could be a constant, it could be constant has a fixed value. It could be a variable. Basically, a variable is just a letter that's used to represent an unknown value. Or you could have products of constants and variables. So the key word is product, which means multiplication. So notice all three of these other terms, they're products of constants and variables. All right, so let's talk about what a like term is. Like terms have variable factors that are exactly the same. So if you look at this first pair here, 3 and 4, these are both constants. There are no variables, so these would be considered like terms. They have the same variable factors. In fact, they don't have any. Here, these each have one x factor. Here, both of these have a single x factor and two y factors. Remember, factors are just numbers that are multiplied. Over here, if you look at our unlike terms, here you have a constant and an x term. They're not considered like terms. Notice here you have two terms that have x's in them, but one of them is just x to the first power and the other one's squared. So they don't have the same number of x variable factors. And then this one here, notice it looks similar, but one of them has a single x and two y factors, and the other one has two x factors and a single y factor. So they're not exactly the same. They're not like terms. All right, so let's move on. So we need to talk about how we combine like terms. Basically, we just add the coefficients. That's just these numbers that are out front. So the number in front of the x. So -7 and 15, when we add those, we get 8. So our answer is 8x. On the next problem there, notice you have -5a and -4a. We add -5 and -4 to get -9. On problem 3 here, or example 3, we can write this using adding the opposite. So this becomes 4x plus -7x, which gives us -3x. Same thing here, we're going to add the opposite. We end up with a plus positive 5x, and so that's 17x. And then on this last one here, notice you're going to be adding a -1 and -5. Again, notice we went from -5y to plus a -5y. Now you don't really have to change forms. In either case, you're adding -1 and -5. So if you want to add the opposite, you can, or you can just start from the very beginning and add the -1 and the -5. So here we do get -6y. All right, so let's do some problems. So on this first one here, we're just adding 3 and 8. We're going to get 11x. Notice the variable doesn't change. On number 2, we're adding 2 and -7, so we do get -5p. So go ahead and do the last 3 here. Maybe stop the video and then check your answers. All right, so what you can see here is all we're doing is adding integers. So -5 and 8, we're getting 3a here. On number 4, you're adding -10 and -17. So you're getting -27. Now be careful on number 5. Remember, we can only add like terms. And so we've got a 5a and a -1a. And so those are like terms. We'll get 4a for those. Then notice we have some constant terms, the 4 and -6. So we could write that as plus -2. But we normally don't write our answers that way. We would use subtraction instead of adding a negative. So this becomes 4x minus 2. All right, on number 6, let's go ahead and add the opposite. We're going to get 6x plus a -15x. So 6 and -15 gives you -9. On number 7, we'll have negative 9x plus a negative 13x, and so we're going to get negative 22x. Again, I would point out that we don't have to rewrite these. On this problem here, you're just adding negative 9 and negative 13. So if it helps to rewrite it, then great, but you really don't have to do that. So again, I'd encourage you to stop the video and try 8, 9, and 10, and then you can turn it on and see how you did. All right, so here we're adding our constants first. We get negative 8 and negative 12, which is negative 20. And then notice we have just a single n term. I call it a loner term. And so don't forget about him. Now the other thing here is mathematicians get a little bit picky about how we write our answers. And actually it's really not so much picky. We just like to have our answers look the same. And so generally normally we put the constant last in a problem like this. And so this is going to be 7n minus 20. Now I wouldn't mark that wrong on this first test, but I would encourage you to get used to putting it in that order. On the next one here we got a couple of constants. That's negative 15. A 4b and a minus 7b is going to be a negative 3b. And again, let's rewrite it in the other order so that we have our constant last. Constants get no respect in algebra. They always go last. Number 15. Well, we've got a negative 5x and a 7x. Those are like terms. That's going to be 2x. We've got a negative 3y and a 1y. And that's going to give us negative 2y. So again, we could write it using addition here, but normally we would write our final answer using subtraction. And I forgot to put a 2 in there. Let me get that in there. All right, let's move on to the next page. So another thing that we sometimes have to do when we're simplifying expressions is, and actually quite frequently, we have to use the distributive property. So that's this property here, where you have a mixture between or with addition and multiplication. Notice we have b plus c. That binomial, two terms, is being multiplied by a. So we multiply the a times the b to get ab, and the a times c to get ac. And notice the plus in between. So this is the distributive property. Let's go ahead and do this in the examples below. So we're going to multiply the 3 times x to get 3x, and 3 times 4 to get 12. And that's all there is to that. Number 12, similarly, we're going to get 18a when we multiply the 9 times 2a. Then we're going to distribute the 9 times a minus 5. We get negative 45. And so we'll write minus 45. So go ahead and try 13 through 15, and then you can check your answers. All right, so here we're going to get negative 24 minus 54x. Let's go ahead and change the order. And again, I would take either of those answers, but the second one is the best. Notice on number 14, we need to be careful here. What are we distributing? Well, anytime you have parentheses with no number out front, it's understood that that's a 1. So we could write this as negative 1 times 2x minus 5. So we're going to distribute a negative 1. And so we're going to get negative 2x. And a negative 1 times negative 5 is going to give us a plus 5. The thing I want you to notice here is we started with a 2x, and now we have a minus 2x. Inside the parentheses, we also had a minus 5, and now we have a plus 5. So that's what happens when you distribute a negative 1. Every term inside the parentheses is going to change signs. So after a while, you just rewrite these and change the signs of the inner terms. Anyway, let's see how you did on number 15. You're going to multiply by that 6. You're going to get 30x minus 18 plus 42y. All right, number 16, we'll multiply the first two terms. Or let's see, the 2 times the 5x, that's 10x, and then the 2 times the 4 is 8. Now notice the minus 3 is not inside the parentheses. We're not distributing the 2 times the minus 3. It's separate. So we'll just bring it down. Now we can combine our 8 and our 3, or minus 3. We're going to get 10x plus 5. All right, let's do number 18 together. I'm sorry, number 17. So we're going to rewrite the 4x, and then we got to distribute the 3. So we're going to get 6x and a minus 15. Combine your x terms together, you're going to get 10x minus 15. So go ahead and try number 18, and then you can see how you did. So on 18, you're going to get 5x and a plus 20 when you distribute. Go ahead and bring that minus 3x down. We've got some x terms. That's going to give us 2x. And then don't forget the 20, and there's your answer. On number 19, notice this is 8 plus 1 times 3x minus 4. So again, bring down the 8, and we're distributing 1. Well, 1 times anything is itself. So basically what we're saying here is if you have a plus in front of parentheses, you can basically drop the parentheses because 1 times anything is itself. So plus in front of parentheses, we just bring down those terms. We don't need the parentheses. So here we have an 8 and a minus 4. We can combine those. Again, we want to put our 3x term first. Let's go ahead and do that, and then the plus 4. All right, let's move on. All right, so on number 20, we've got a problem just like that. We can bring down the 4. Again, because we have a plus in front of parentheses, it's just a 1 times that. We really don't need the parentheses there. We get 2y plus 3, and then don't forget to bring that y down. You're going to have 3y. 4 and 3 is going to give you 7. Let's move on to 22. We're going to bring down the 4x plus 2, and now we're distributing a negative 1. Remember, that's going to change each of our signs. So the 3x is going to become a minus 3x, and the 7 is going to become a minus 7. Again, distributing by a negative 1 is just changing the signs of each term inside the parentheses. So we'll combine our like terms, and we're going to end up with x minus 5. All right, let's do 24. We're going to bring down the 8x and the minus y. Now we're distributing a negative 4. So we'll get negative 12x. So we'll write that as minus 12x. A negative 4 times a negative 2y is a positive 8y. And when we combine our like terms, we're going to get negative 4x here. Let's see, we got a negative 1y and an 8y. That's going to be 7y. All right, so I'd encourage you to try 21 through 20, or 21, 23, and 25, and then you can check your work. All right, so we're going to have 5 minus x plus 2. Notice both of our terms inside the parentheses change signs. We can combine the 5 and 2 together, and the x is just going to stay out front. Let's go ahead and distribute the negative 3, and then distribute a negative 1. So both the x became a minus x, the minus 7 became a plus 7. Again, we can think of that as distributing a negative 1. So we're going to combine a negative 6x with a negative 1x. So negative 7x, we got a negative 12 and a positive 7. So negative 5, we'll write minus 5. All right, one last one here. You're doing 4 times 3a to get 12a, 4 times 2b to get 8b. We're going to distribute a negative 3 now. We'll get negative 3a and plus 15b. Let's combine our like terms together. You end up with 9a plus 23b. All right, let's move on. So here we're actually going to be evaluating expressions, which means we're going to get a number as a final answer. So one of the things you'll find with order of operations is it gets a little more challenging when you start working with negatives. So I'm going to give you a little bit of practice doing what we did previously, but we're going to be using negative numbers. So if you want, you could go ahead and try all these problems, or watch the ones you want to watch me do and try some of the others. All right, so let's go ahead and get started. Here we have the opposite of negative 8, which is positive 8. The other way to think of this is as negative 1 times negative 8. On number 2, remember we got to be careful with knowing what the base is. On number 2, our base is just the 6. Again, if an exponent is next to a number or a letter, it only applies to that number or letter unless you have parentheses. So here my base is 6. So we're going to square 6 and apply the negative. We end up with negative 36. Notice the difference on number 3. Everything inside the parentheses is my base. So my base is negative 6. So we're going to multiply two negative 6's, and here we get a positive 36. Now be careful with a number like, or problem like number 4. Notice we have a subtraction and a multiplication. And we multiply before we subtract. So let's do that first. I'm going to go ahead and bring down the 20 minus. Again, I'm going to subtract last. 3 times negative 6 is negative 18. Notice I'm multiplying 3, a positive 3, times negative 6. So we get negative 18. So it's 20 minus a negative 18. We'll get 20 plus 18, which becomes 38. Now some of you may have just multiplied negative 3 times negative 6 and went right to 20 plus 18. And that's fine. But I just want to stick to the order of operations for now. And as you get better with order of operations, you realize some of the shortcuts that you can take. On number 5, let's go ahead and add the opposite there to make this a little bit cleaner, a little bit nicer. And so we got negative 5 and 9 is 4, and 14, we're going to get 18 there. On number 6, when we divide, again, division and multiplication. Notice that 2 next to the parentheses, negative 4, that's multiplication. These are equal priority, so we do the one on the left first. We're going to get negative 12 times negative 4, and so that's 48. On number 7, let's simplify inside the parentheses first. We're going to get 5 times 4. In the denominator, we get negative 8 plus a negative 2. Or we're adding negative 8, negative 2 to get negative 10. We're going to get 20 over negative 10, which is negative 2. On number 8, we want to, let's see, do the exponent first. So we're squaring negative 3. Now be careful here. Negative 3 times negative 3, that's a positive 9. And so then we multiply, we get 36. On number 9, we're going to work inside the parentheses first. And 2 minus 10 is negative 8. And so now we'll apply the exponent. We get 36. Let's go ahead and add the opposite here. And so we're going to get 44. On number 10, we got to start simplifying inside the parentheses. We're going to get negative 3 there. Next comes the exponent. So our base is negative 3. And negative 3 times negative 3 is 9. Now notice we're multiplying what we get out of that times 2. So we'll do the multiplication next, and then the addition last. Remember, adding and subtracting always comes last. Like if you're in parentheses, that's the last thing you do. But in any problem, addition, subtraction comes at the end. All right, number 11, 3 times negative 7 is negative 21. In the denominator there, we've got 3 plus a positive 4. If we add the opposite, that's 7. And this is just a division problem. 21 divided 7 is 3. We're going to get negative 3 here. On number 12, let's go ahead and let's see what the brackets there are just really parentheses. The bracket helps things to stand out a little bit better. That's why we don't use parentheses in both places. And with this type of problem, we start on the inside and we work our way out. So here I'm going to rewrite everything. So the 4 and the 6 plus 2, and the only thing that's changing is 3 minus 7 becomes negative 4. Now notice that what you got there is going to be multiplied by 2. And we'll do the multiplication next, and again the addition last. So we're going to have 4 times negative 2. by the way, I could be using a parenthesis here if I want. It's just kind of personal preference. And our final answer is -8. All right, on number 13, you should have gotten 0. We said previously 0 divided by any number is 0. Let me show you why, or let me give you some justification. Notice I could write this as 0 divided 4 equals 0. So I want to show you something up above here. If you have 6 divided by 2 equals 3, which we all know is true, remember division and multiplications are opposites, so it should be the case that 3 times 2, if you go backwards, equals 6, and that's true. So notice in our problem, it should be the case that 0 times 4 equals 0, which it does. Now, division by 0 is something different. It's actually undefined. Why is that? Let's go ahead and write this one out. -5 divided by 0 equals some number. Well, let's see. What we're saying is we're looking for a number that times 0 gives us -5. There's no number that's going to multiply times 0 and give you -5. And so you can see that just doesn't work out at all. Division by 0 just is undefined. Let's go on to 15. Again, with multiplication, we can multiply in whatever order we want. Let's pair these up, and we're going to get -6 and 20. And when we multiply, we get -120. All right, let's try to wrap this up. Oh, I just want to remind you, we can easily use a calculator to check these guys. Make sure that you can do that. You should never miss one of these on the test as far as the final answer is concerned, because all of these can be put into a calculator and you can see that these are the correct answers. So make sure you practice that. All right, so now we're going to talk about evaluating expressions when we're given the value of the variable or variables. So the first thing I would say here is I want to give you a little tip. I want you to begin by making a shell, or what I call a skeleton, for the expression. So basically, wherever I see an x, I'm going to put parentheses. So this is my shell. And now I'm going to replace, well, I'm going to basically substitute the -3 where the x was. And once you've done that, this is just an order of operations problem. You're going to get -12 minus 2, which is -14. Let's go ahead and do the same thing for number 2. And let's plug in our 6. And again, let's use order of operations. We're going to get 36 minus 12, which is 24. Same thing on number 3. Let's plug in our -3 and follow the order of operations. So exponents first. Notice I already added the opposite. Then let's multiply. And last but not least, we add. And then we got one more here, a squared minus 3ab. Let's make our shell. Let's plug in our numbers. Make sure that you're getting those numbers in the right place. All right, and then we follow order of operations. So we're going to square that -4 first. Again, a -4 times -4 is 16. Now notice here we have a subtraction and 2 multiplications. So the subtraction is going to come last. So let's go ahead and write the 16 minus. And now we've got 3 times -4, which is -12, times 2, which is -24. So we're going to end up getting 16 plus 24, which is 40. So see if you can do number 5. Stop the video, and I'll give you the answer in a second. All right, you should have got -56. And that's it for this video.